welcome you to my lecture today. Of course, I'm actually going to walk you through another exciting topic in statistics. I think I told you before, statistics is like a story, or a story that goes on and on and on. Now, the topic today is actually going to be fundamentals of hypothesis testing. But how do we find ourselves in a situation where we actually need to test hypotheses? I want to tell you, we live in a stochastic world where different things happens in different days. We got a lot of variations in this world. And you know what? If somebody come out with a claim, then we needed to investigate. Okay, before I accept what you tell me, I think I need a little bit of investigation. So what you want to learn from this topic is just what is a statistical way to conduct an hypothesis testing? Because we don't want to live in a world of where the people use what I call the principle of authoritarianism, or indoctrination, where somebody is going to say, okay, that is that, and we just accept it like that. No way. We need to investigate. Okay, so in the objective, I'm actually gonna, in the objective, this objective actually revolve around procedure, statistical procedure, for conducting an hypothesis testing. I want to conduct an hypothesis testing now. I may want to conduct hypothesis testing about the population mean, or the population variance, or the population standard deviation, or a population proportion. What is the difference between what we want to do now and what we have been doing before? But I want to tell you this. Statistical inference can be divided into two. I'm going to say that again. Statistical inference is divided into two. Number one is estimating. Okay, what I've walked you through before, I've walked you through estimating population parameter. And the second one is what we call the hypothesis testing. What we did under the estimating parameter is we estimate population mean. I walk you through how you can also set up an interval estimate for the population mean. We did that for one population. We also did that for two populations. Okay, in estimating parameter again, I walk you through how to obtain the points and the interval estimate of the population proportion. We did that for one population. We also did that for two populations. And not only that, I also walk you through how to estimate a population parameter variance. Where I walk you through how you can get a point estimate. I also walk you through how you can get the interval estimate. We did the same thing to standard deviation. We did for one population, we did for two populations. Okay, that is one aspect of statistical inference that we call estimating. But what we are starting now, another aspect of statistical inference is when we conduct an hypothesis testing. Okay, I'm actually going to move fast. What do we mean by hypothesis? Because our mind, M-I-N-D, can never be empty, there is always something that is occupying our mind. We're always going to have a claim. I'm going to say that again. We're normally going to have a claim. And what do we mean by hypothesis? Hypothesis is an assertion about the value of a parameter. That is what we mean by an hypothesis. And you know what? If somebody come out with a claim, okay, and we now want to investigate that, then that is what we call hypothesis testing. What does that mean? Testing the validity of a claim. The Pfizer, the Moderna, the Johnson & Johnson, the AstraZeneca, they actually claim, to have developed a COVID vaccine with certain efficacy rates. Do you know we can actually test? Is it true that the efficacy rate of the the Pfizer vaccine is 95%, we can actually test that under the hypothesis. Okay, so that is what we call the hypothesis testing. So I'm going to walk you through. Take a look at this example. Anyone can make a claim about a population parameter, I told you. And probably you've asked something like this. Somebody said 4 out of 5 dentists prefer Star Bright toothpaste. That may be true. That may not be true. The only way to know whether it is true or not is to conduct an investigation. Okay. Somebody said less than 1% of dogs attack people unprovoked. Oh my God, that may not be true. And that could be true. The only way to unravel, the truth is just through investigation. We're going to continue to investigate. We live in a world where things are changing, and we need to adjust with the world. You get what I mean, right? Okay. Now, and let me tell you this. In hypothesis testing, so officially, I'm actually going to say hypothesis testing is, one statistical process that set a uniform standard for evaluating, type of claim. Okay. Now, like I said, not only in statistics, in science in general, we investigate. Okay. And let me give you some example again. The popular, somebody could claim that about the popularity of the president of any country. Okay. If they have a claim that the popularity of a president or the proportion of citizens that approve the work the president is doing is this, okay, we can actually carry out an investigation to see whether it is true or not. Because we have a lot of news around, some news may be politically, or I'm going to say politically fabricated news. Okay, so, and that is why the only way to tell is through statistical investigation. Okay, let me now tell you this. The very first procedure in conducting an hypothesis testing is to specify the known and the alternative hypothesis. I'm going to say that again. The very first procedure is the specification of the known and the alternative hypothesis. Symbolically, we use HO to represent the known hypothesis, and we use HA to represent the alternative. Now, let me tell you this. The two hypotheses, they are mutually exclusive because we're actually going to accept one at the end of the day. And I want to tell you, this is synonymous with what happened in the court of law. In the court of law, the court actually has two hypotheses before then. The first one is going to be the accused person is innocent. And the second one is going to be the accused person is guilty. But you know what? At the end of the day, the court must take a position. And that is the same thing we do in research. We set up two hypotheses based on the research question. And at the end of the day, with the criteria, we're actually going to take a decision on whether to reject the non-hypothesis or not. Okay, so the non-hyp now, when you have a question, I'm confirming this in the exam or anywhere in the world, you are given an hypothesis question and they ask you to identify what is your non-hypothesis, what is your alternative. The non-hypothesis is actually the hypothesis of the primary of interest. Then the alternative hypothesis is actually going to negate, it's going to go against the non-hypothesis. But I'm going to give you a strategy now that is going to work for you anywhere in the world. There are 3 signs. There are 3 symbols that you can actually have under the HO that I call the non-hypothesis. What are the 3 symbols? I want you to pay attention now, and you're going to get the 3 symbols. The first symbol is equality sign. I'm talking about HO right now. The second symbol is less or equal to. The third symbol is greater or equal. Oh, give me 1 second. I'm going to write that on the board. Those of you online, I believe you can also see the board, right? Can you see the board? Those of you online?
Yep.
Okay, thank you so much. Now, this is what I'm saying. HO, there are three possible symbols HO can take: equality, or less or equal to, or greater or equal to. For the alternative HA, we got three possible symbols as well: not equal to sign, less than sign, or greater than sign. This is the strategy. And you know what? If I identify my alternative hypothesis, then I will be able to get my non-hypothesis. For instance, if my alternative is not equal to, the direct opposite of not equal to would be the symbol in the non. Okay, it means this is gonna always go with that. If the alternative hypothesis is less than, what is the opposite of less than? It is greater or equal to. They will always go together. If the alternative is greater than, then the opposite of that is this. Yeah, go ahead. Question. That's a very good question. If I hear you clearly, you are asking whether we normally take decision with respect to the non-hypothesis, the way also take with respect to the alternative, right? Is that what you mean, right? Okay, now the answer is this. If we want to take a decision, it is always about the non-hypothesis. If I reject the non-hypothesis, what does that mean? It means I'm favoring the alternative. If I fail to reject the non-hypothesis, what does that mean? I'm favoring the non-hypothesis. Does that make sense? So when we are taking decision, we normally take decision around the non-hypothesis. But since the two of them are mutually exclusive, this is basically what happened. Just like in the court of law, the non-hypothesis is going to say the accused person is innocent, right? Alternative is going to say is guilty, right? If I fail to reject the non-hypothesis, what am I telling the world? If I fail to reject the non-hypothesis, what am I telling the world? That is innocent, right? Send message to me for extra credit. Okay, when I fail to reject the non-hypothesis, what it means is that he is innocent. When I reject the non-hypothesis, what am I saying? Rejecting the non-hypothesis means I'm going for the alternative. But when we are taking decision, we normally take decision around the non. Does that make sense to you now? Okay. Now, if that is going to be the case, now I think I've given you the strategy to use. Okay, I'll quickly do something now. I'm going to go into an example. And in this example, they're going to ask you to specify what is your non-hypothesis, what is your alternative. Okay, now let's take a look at that. Determine the non and the alternative hypothesis for the following scenarios. Okay, at Northwest Mississippi College, Community College, the syllabus for online courses states that students should expect to spend 10 hours per week doing coursework for each 3 credit hour class. The director of e-learning for the community college is concerned that the students are being required to spend more than 10 hours per week. Oh my God, look at that. More than 10 hours. That would be greater than sign. Where are you going to have a greater than sign? You're going to have a greater than sign as the alternative. And the moment you know the alternative, what would be your HO? Your HO, we have that sign. And that is the reason why at the end of the day, I have this. Is there anyone who want to ask question? In that now, in the specification now, okay, the non-hypothesis is greater than. Why do I put mu? I put mu because we're talking about mean. And the parameter that will represent mu in the specification of hypothesis is actually going to be mu. Let me put this down. Okay, so I think you get it now. We are done with question 1. Okay, we are done with question 1. And where do we have claim here? An examiner can also ask you, where do we have claim? We have claim at the alternative, because the director of e-learning said students spend more than 10 hours. So the claim is at the alternative in this question. The claim can be in the alternative or it can be in the non-hypothesis depending on the question. Like in this question now, you got a claim in the alternative. Okay. Now, okay, go ahead. No. I understand what you mean. For now, we don't know whether it is any of the hypothesis is true or not. What we're just doing now, okay, we're just specifying, okay, but you know what I just said now is that you have your claim can be at the alternative, claim can also be in the non-hypothesis, but based on this question now, because the director said students spend more than 10 hours. Where is our claim? The claim is going to be at the alternative because we know that the alternative we have a greater than sign. Does that make sense? Okay. Yeah. You want to ask a question? Yeah. Because what we always want to test is this. Is the non-hypothesis true or not? But I want to say, because of the error in research, because I'm also going to go there is possibility that, the nature always know the truth, right? Let's say the reality have it that the non-hypothesis is true. There's possibility that the evidence before us, we may reject that. You get what I mean? And I think I'm still coming to that, but the fact remains that we are, even if the claim is at the alternative, we are always testing whether the non-hypothesis is true. Does that make sense? That's a very good question. Okay, now I'm going to go into another example now. Okay, we are still determining the non and the alternative. Okay, after learning that Peter Collard of Switzerland could hold his breath for 19 minutes and 21 seconds underwater, a group of students decided to conduct their research, to conduct their science fair project around the amount of time an average adult can hold his or her breath. Part of the group found research to suggest that adults can hold their breath for 30 seconds when submerged in Lock 1. They can hold it for 30 seconds. That is equality. Okay. Now, and the other half of the group found evidence to suggest that the mean time is different. Oh my God, is different. That is not equality, right? Okay. Now, the group would like to test this claim, okay, about the adult holding their breath in cold water, of course, automatically is going to be this. This is the specification. Is there anyone who want to ask question about how we arrive at this? Okay, okay, go ahead. Exactly. Exactly. The moment you identify one hypothesis, then the other one is going to be direct opposite. Because they say, oh, for this, then the other hypothesis is going to be not equal to that. You get what I mean? Okay. Okay. Now, if you look at the example 1 and 2 that we did, actually centered on me. And when we are specifying hypothesis that has to do with me, we always use mu. Okay, mu. You don't use S bar. Okay, you don't use X bar. Okay, we use mu because why is it that we don't use X bar? X bar is a sample mean. We are testing hypothesis around the population parameter value, not around the mean. I mean, not around the sample mean. The population, this is a symbolic representation of the population mean. That's a parameter. Okay. Now, in the next example now, we want to look at proportion. How are we going to identify the known and the alternative when you are given a proportional question? Now let's take a look at this. A leading news authority claimed that the president job approval rating has dropped. Look at the English. Dropped. Oh, that's a decrease, right? That's a less than. Pay attention to word. Okay, has dropped over the past 3 months. Previous poll put the president approval rating at a minimum rate of 56%. Oh my God, it means initially the approval rating of the president was 56%, but now they observe that it has dropped, right? Okay. The president's chief of staff is concerned about this news report since it is an election year and they want to run a test on the claim. What is the claim here? The claim is going to be in the alternative because they say it has dropped. If I want to specify that, oh my God, this is what I'm going to have in the alternative, it's going to be a less than. In the non-hypothesis, I'm going to write it, I'm going to have the direct opposite of that. And when I'm specifying proportion, I'm going to write P. You were given 56%, you're going to do 56 divided by 100, and that would be 0.56. When you are specifying something that has to do with the proportion, even if you're giving something in percentage, don't write 56%. Write it in decimal. Please take note of that. Okay. Now, I believe you now understand how to identify both the known and the alternative hypothesis. Okay, now the next step is this. Test statistic. The test statistic is actually the formula that we're actually going to use. Okay, it's just like in the court of law. After they announce, to the court about the case, where they're going to say, they have 2 hypotheses. Then the next thing is going to be cross-examination. You know that, right? The cross-examination of the witnesses. What we do in statistics and what we're doing in research, or what we do when we are testing hypotheses, after we have stated our known and the alternative, the next thing is what is the test statistic that we're actually going to use. Now, you remember when I was walking you through the confidence interval the other time, when we're trying to construct a confidence interval for mean, I consider a situation whereby the population standard deviation is known, right? I also consider a situation whereby the population standard deviation is not known, right? And of course, in the margin of error formula, of course, you saw the margin of error formula that involves z-score, and you saw a margin of error formula that involves a t-score. But right now, we have different kind of tests that can be conducted. If I want to conduct a test on the population mean, now the question now is the population standard deviation is known? If it is known, then I'm going to use a z-test. If it is not known, then I'm going to use a t-test. Okay, so that is the next thing that we want to do now. Okay, now, and after that, we need to know the level of significance of the test. The level of significance is the level of statistical error. There is no any research anywhere in the world that is error-free. And I'm going to tell you now, we have errors in research, which we are also going to discuss. And that is the reason why when we are working, we need to disclose a level of significance. In my recent work, in an article that I'm actually going to publish next, where I'm trying to apply the probability theory in the law practice, what I recommend to the court is that courts, when they are listening to a case, courts should also tell the world their level of error, because the court is not perfect. Because there is possibility that somebody who is supposed to be in jail may be discharged and acquitted. And somebody who actually did not commit the offense may be convicted and prosecuted. Let me tell you this. I watched a documentary like 2 days ago, and I saw a news about somebody who after spending 40 something years in prison, and they discover he's now innocent. Because we live in a probabilistic world, okay, where there's possibility of error. We can make error. And that is why the level of significance here is trying to tell you what is your level of your statistical error. If it is 5%, you know what you are telling the world? You are telling the world that you actually your research will mislead the world 5 times out of 100. That's okay, which means you are 95% confident. That's what we mean. Okay, that has to be given. Okay, and let me tell you this. We're going to have 2 forms of Z-score when we're using a Z-test. We're going to have, I'm going to show you, we're going to have what we call, I'll take a look at this. Yeah, we're going to have this one. That's a Z calculated. And we're going to have another Z-score that we're going to check from the table. Then we're going to have a way to compare them, and we're going to take a decision. But I'm still coming back to that. Okay, I'm still coming back to that. Now, what I want to walk you through now is basically how do we conclude? For instance, you've taken a decision and you actually want to conclude. Okay, how do we conclude? I told you, we take a decision around the non-hypothesis. It's either we reject it or we fail to reject that. When the non-hypothesis is rejected, you know what that means? Then it means you have a sufficient evidence to do so. If you fail to reject the non-hypothesis, then it means there is no evidence. There's no sufficient evidence to do so. Okay, now, what I want to show you now, I actually want to walk you through how do we interpret the conclusion to a hypothesis test. At Northwest Mississippi Community College, syllable for online, okay, the same, I think we've worked on this example, but the only addition here is that, the director actually claims students spend more than 10 hours, right? Now, the hypothesis here, a hypothesis test with a 5% level of significance is performed on the director's claim, and the result is to reject the non-hypothesis. Now, the question now is, does the conclusion support the director's claim? The question is, what is the director's claim? Director's claim greater than 10, right? Let's go to the specification again. This is the alternative is the director's claim. The non-hypothesis, we go against the director's claim. And we were told that the conclusion is that is to reject the non-hypothesis. Okay, rejecting this guy here, what has happened? Rejecting the null means you are in favor of the alternative. What does that mean? Oh my God, the director's claim is right. That is the meaning. It means the decision you took is in support of the director's claim. Does that make sense to everyone? That is what it means. Okay, and that was what I put it here. Okay, oh, the director will be confident and say, I told you. That's what the director is going to say. Okay, now, another one now, look at this. This is another example. Based on historical data, the Board of Education from one large school district believe that the percentage of high school sophomore considering dropping out of school is at least 10%. Oh, at least 10%. That's a greater or equal to sign. I want you to, pay attention to the words. At least means greater or equal to. At most means less or equal to. Okay, now you know where the Board of Education claim is going to be, right? Okay, because they say at least, which is greater than or equal to, that would be on the non-hypothesis. Okay, a high school counselor in the district claimed that this percentage is too high. When you say it is too high, of course, you know the claim of the counselor now. The claim of the counselor now is going to be that it is less, right? Okay, now they now say a hypothesis test with alpha equal to 0.02 is performed on the counselor's claim. Okay, on the counselor's claim. Of course, the counselor's claim is on the alternative. Okay, why and the non-hypothesis is the board of directors claim, right? Now, the result is to reject. The result is to fail to reject the non-hypothesis, failing to reject the non-hypothesis. Do the findings support the counselor's claim? Now, let's look at the specification. In this specification now, okay, in this specification now, the board of director claim is at the non-hypothesis. The district counselor is the alternative. When you fail to reject the non-hypothesis, oh my God, that does not favor the counselor. Does that make sense? That does not favor the counselor. That actually favor the board of education. And that was why I said since the test resulted in a failure to reject the non-hypothesis, the evidence is not strong enough at this level of significance to support the counselor's claim. That is what it means. Okay. Now, I think I've walked you through how you can correctly specify the non and the alternative hypothesis and how you can interpret your conclusion in an hypothesis testing when you have taken a decision. Taking a decision is different from conclusion. I'm going to say that again. Taking a decision, which means decision rule, is not the same as conclusion. It is more or less like in the court of law. If maybe after the cross examination, and they now say, "Oh, this guy, you are guilty." When this guy is guilty, they've not make a sentence. There's a difference between when you find somebody guilty and the sentencing is going to be another time. Because before they could sentence, they have to look at some history, aggravating factors and so on like that. So what I'm trying to tell you now, decision rule is different from conclusion. Okay, now, of course, in performing hypothesis testing, this is a procedure we follow. But let me tell you this. I also wanted to know that we actually have two types of errors in hypothesis testing. Okay, number one type of error is what we call the type 1 error, and the second one is what we call the type 2 error. What do we mean by type 1 error? When the non-hypothesis is true and it is rejected, it's possible. The non-HO is true because the nature knows the truth. If the non-hypothesis is true and it is rejected, that's a type 1 error. And we use alpha to denote that. Okay, when the non-hypothesis is false, okay, and it is accepted, that's a type 2 error. We use beta to represent that. Okay, so the two types of error in the court of law are also two types of error in research. And that was why I put a look at that. The one, probably the type 1 error, the non-hypothesis is true and it is rejected. And the type 2 error, the non-hypothesis is actually false, but it's not rejected. And the one in the green, oh my God, the one in green is correct decision. And what is the meaning of that? The non-hypothesis is true and you fail to reject, or the non-hypothesis is false and you reject that, that's a correct decision. And you know what? We also call that power of a test. Power of a test. The power of a test is the ability to take correct decision. I'm going to say that again. The power of a test is the ability to take correct decision. What does that mean? Rejecting the non-hypothesis when it is false and fail to reject it when it is true. That's a correct decision. Okay. The next thing that I want to walk you through now, what we normally do in research is to minimize these two types of errors. But no matter how we try, it can never be zero because we live in a stochastic environment. Our research can never be error-free. Okay, and you know what? We are always concerned about type 1 error. Do you know that the alpha that we call the level of significance is the maximum probability of committing type 1 error? I'm going to say that again. Alpha level of significance is the maximum probability of committing type 1 error. That is what we call alpha, which we call the level of significance, which can be 5% or 1%. If it is 5%, you know what you are telling the world? You are telling the world that your maximum probability of committing type 1 error is 0.05. So which means you are only going to mislead the world 5 times out of 100. That's okay. So which means you are 95% confident. That is what it means. Okay. Now, what I want to walk you through now, how do we actually, how can you identify whether an error is committed in a research or not? And if an error is committed, how can you identify the error to be type 1 or type 2? That is what I want to explain in this example. Okay, now before you can actually know whether an error is committed, then it means you already know reality. I'm going to say that again. Before you can actually know whether error is committed or not, it means you now have the values of reality. Now let's look at the example. A television executive believes that at least 99% of households in the United States have at least one television. Look at that. At least 99. That's a greater than or equal to sign. Where is it going to be? It's actually going to be in the HO, in the non-hypothesis. You know that? And of course, the opposite of that will be at the alternative. It's going to be less than. Okay. And in time at the executive company is given the task of using hypothesis test to determine whether the percentage is actually less than 99. Okay. The hypothesis test is completed. And based on the sample collected, the intern decide to fail to reject the non-hypothesis. The intern refused, it did not, reject the non-hypothesis, okay? And if in reality, 96.7% of the household owned a TV set, was an error made? If an error is made, what type of error is that? But if you want to answer that question, the first thing you need to do is formulate your hypothesis. Okay, this is the belief, okay? And at the end of the day, he failed to reject this, right? When he failed to reject it, but in reality, okay, it is actually 96.7. Where does 96.7 lies here? It is here. 96.7 is less than 99%. But this guy failed to reject. What does that mean? It means the non-hypothesis is wrong, but he failed to reject that. That's a type 1 error. Did you get that? So that is the kind of error that was made. Okay. Oh, sorry. I want to say type 2 error. So that because the type 1 error is when the non-hypothesis is true and it is rejected, and the type 2 error is when it is false and it's accepted. So that very error, here, this one is false. Why do I know it's false? It's false because in reality, 96.7 is less than that. Yeah, go ahead. Okay, you know why we're taking it as a non-hypothesis? Because they say at least. And where can we have at least? Greater or equal to? Where can you have greater or equal to sign? Always at the non-hypothesis. No, I said that at the beginning of the class that we got 3 possible symbols under the non-hypothesis. It's either you have equality sign, or greater or equal to sign, or less or equal to sign. Yeah, I think I get what you're trying to say. Now, this is the key. I'm still coming for you. Okay, I'm still coming. I'm sorry. Now, this is just this. I have a strategy here. We got three possible symbols that can be in the non-hypothesis, and we also get three possible symbols that can be in the alternative. Okay, the three possible symbols in the non-hypothesis are equality sign, or less or equal to sign, or greater or equal to sign. Okay, there is no any other symbol that can be in the null. In the alternative, it is strictly not equal to, or less than, or greater than. Now, how do I know that this is going to be in the null? Because in the statement they mention at least. How can I interpret at least? That's a greater or equal to.
So if the statement had been said otherwise, had said
at most.
if he said if like over 99% more than 99%, then
that would be weird. Now tell me, more than. That's a greater than.
that's the alternate, and the other one
That would be in the alternative. Good job. So if more than is at the alternative, then you can determine the null. The direct opposite of that would be the null. I think it's making sense, right?
I mean, it's how you find
No. It is not a matter of how you define it, because we have a formula. The formula is just.
there's a specific word, just like how you find things at the start.
I think what you need to pay attention to is, okay, how do I know I'm dealing with a greater or equal to sign? If they mention at least. Okay, if I want to use less or equal to sign, if they mention at most. Okay, let me listen to you. Okay. Is it when I get here, you tell me? Okay, you want forward? Okay. Oh, okay. Now, this is what happened. I think I've just given you the kind of. So in this question now, because they mention at least, and you know where at least is going to be. At least is greater or equal to, and greater or equal to will always be at the non-hypothesis. And what is the opposite of greater or equal to? It's less than. Okay, but you know what? What happened in reality? This person, failed to reject the non-hypothesis, which means he also agreed that it is more than 99%. But you know what? What happened in reality? What happened in reality is 96.7%. Now, where is 96.7%? The 96.7% is actually here. So therefore, she's supposed to have rejected this, but he did not reject that. Okay, he did not reject that, then he has committed type 2 error. Now, I'm going to quickly go into another example now. Now, let's take a look at this. This is going to be the last example. We're going to continue from this material next time, but this is going to be the last example. Insurance company commonly use 1,000 miles as the mean number of miles a car is driven per month. One insurance company claimed that due to our more mobile society, the mean is more than 1,000 miles per month. Look at that, more than. What kind of sign is more than? What kind of sign? You say more than. What kind of sign is that? Greater than, right? Where is it going to be? Extra credit. Okay, everybody said alternative. Everybody said a message to me for extra credit. Yeah, I said alternative. Now, it said more than that. The insurance company tests its claim with hypothesis test and decide to reject the non-hypothesis. Assuming that in reality, the mean numbers of miles a car is driven per month is 1,250. Was an error made? If so, what type? You know what you're going to do? Let's first look at the hypothesis. This is the hypothesis, right? Okay. And they said he rejected, right? When he rejected, where are we? He rejected this, we are here, greater than 1,000. Now, let's see what happened in reality. What happened in reality is 1,250. 1,250 is greater than 1,000, which means there was no error made. And that was why I said he made a correct decision. There was no error made. I'm actually going to stop here today. We're going to continue from here next time, but I quickly have an announcement before I go. Some of you have reached out to me about what is it called? Using linear regression. You know, we're not going to cover linear regression in this class, but you know what? If you still want to use linear regression, if you understand that, there is no problem. But I want to give an opportunity now. I'm supposed to, I'm invited to make a presentation in Africa, particularly Nigeria, but I decided not to go. I decided because of COVID and I want to have that online. So on Tuesday, if you actually want to witness my presentation, I think this presentation will also touch something that has to do with modeling in general. It's going to touch linear regression and so on like that in general. You can actually join the Zoom because I'm actually going to be making the presentation on the Zoom. I'm going to share the link to the announcement section for those who want to join. It is Tuesday, 8 a.m., December 7th, where I'm actually going to be discussing models. But let me tell you this, even if you are not working on linear regression, probably you may want to use certain knowledge or statistics in the future because it's going to be recorded. You can ask any question there, then you can save the video for future use. Okay, so if you're interested, you can join on December 7th on Tuesday by 8 a.m. Okay, make sure you stay safe and have a very beautiful day.